Ethics is a complicated concept if you think about it, because it can encompass so many things. It could be something you study in school, in a course. It could be the kind of things that you learn from your parents or your grandparents on how to be a better person and make better decisions. It could be something that relates to the law and obligations that we have as professionals for one thing or another. Or in general, it's a very personal thing and kind of thing that guides you through life as you encounter more and more complex things. So ethics kind of involves all of these things, and this is important for our project because all of the projects that you'll be working on are really strongly related to infrastructure and really society in general. So whether we're talking about the masses of people driving their cars to work and clogging our streets, or securing the safety of clean water for everybody, finding a good place to live that's affordable and comfortable for everybody, or what to do with all the stuff that we use up and throw away and how we deal with that. All of these kinds of things, as you can imagine, impact impacts everybody. So the decisions we make has to consider more than just, does this thing perform according to spec, a technical specification? It is a much more complex challenge to deal with things ethically. Okay. Now, in Canada, we have a unique situation because the engineering profession is a self-regulating profession. What that means is we actually have a framework, a legal framework, a legislated framework by which people called engineers are able to make good decisions on behalf of the public. And in fact, as this chart is showing, and as all of these points are indicating, there's many different guidelines and frameworks that have been developed that are robust and that over time all of you will learn about before you graduate from this program, where you'll learn some of the details, and hopefully all of you will also go through this process and begin practicing these details. So in some sense, the laws and the governance of our society in Canada gives us some framework as engineering professionals to do the right thing, to be ethical. Is that enough? Well, one of the things that's happening is, well, we're becoming a bit more sensitive to this notion of unintended consequences. Like, what are unintended consequences? Well, anything that we design, we have some thought of what it's supposed to do, right? And so we pay some close attention and we try to predict, is it going to work? And then hopefully it works and it does what it's supposed to do. But what if it goes and does something that you didn't want it to do and it's harmful? So even if you were a really good, decent person, you were raised well, you treat each other kindly, and you put a lot of hard work and you're diligent, we are now dealing with a lot of systems and technology that are fundamentally complex, where things can go into unintended or unexpected ways, and it may cause harms. And a good example, smartphones. Yes, we pioneered smartphones in this country. The BlackBerry, it was invented here, and it launched the smartphone revolution, and it was wonderful. We could now communicate with all sorts of people, get access to different types of data and information wherever we are. It was great. But for a lot of people, it's over time it's ended up causing a bunch of problems. And this picture kind of pokes fun at that. It's become this thing that we're addicted and chained to. But there's other examples that might be a bit clearer. Road salt, yeah, we need it for safety in this country in the winter, but it's also wreaked havoc on our agricultural system and our water systems because of the salt runoff. Anything to do with plastic. When plastic started, it was invented, it was considered a miracle substance because it kept things clean. You can keep food fresh, and it also allowed for more efficient packaging because it was lighter, it was safer, it was so many things. But we all know what happened since then. We just use too much of it and we don't know what to do with it after the fact. Semiconductors, circuit boards, all of those things made the digital revolution happen. And many good things happen. And that stuff worked exactly as intended, in that it made high performance computation and advanced devices much more easily much easier to design and manufacture and actually deploy into usage. But now we have mountains of e-waste and tons of toxic, highly toxic material that we don't know what to do with, as well as the general social concerns about what all of this digitization has done in terms of issues that we have with social networks and other types of screen time issues that we're all facing. Finally, anything to do with automation. Yeah, our cars are cheaper, they're safer, they're higher quality, but the emergence of mass levels of automation has also disrupted a lot of our communities. All of these great engineers contributed to creating these solutions. They were good people, they worked hard, and they were ethical in many ways, but ultimately it ended up going into some unforeseen places. And this is becoming a problem. And in fact, we when we develop courses that you learn from in engineering programs, and a lot of it's based on this notion that things are well defined enough that we're going to learn techniques to help you design it and to analyze, and that's great. But over time, what we're finding is these things are becoming more and more complex. Initially it was they're getting more specialized, we're demanding higher performance. Great, we're going to add this to it or make it out of this more superior material or increase functionality here and there. That was fine. And then came the process of things getting connected and networked. They're sharing things and they work in a way where, yeah, we can predict what individual pieces might do, but collectively it starts getting a lot trickier. Now we have the situation today of also some things are able to change its behavior. They're adaptive, or in cases with things like machine learning or AI, they actually can make certain types of decisions and impact the function of the things that they're connected with on their own. That in fact we program them to make decisions and change their behavior, which really increases the unpredictability. When all is said and done, all this increase in complexity of the things that we work on as engineering professionals fundamentally make things less predictable, and the chance of unforeseen or unintended consequences that much higher. There's a technical term that you might hear over and over again, and that's deterministic versus non-deterministic. There was a time when things were relatively well defined enough that we could actually, using mathematics and simulation, predict whether it was going to be good or bad in function. But as things became more complex, they are now profoundly non-deterministic. And even the best of us with the best intentions will be challenged to figure out how to deal with complexities that we're not anticipating. So what can we do about it? Well, here's one thing. So some people have started working on ways of just questions for you to ask as you are staring at complexity in the face. And rather than simply looking at the technical specification, think about the people that it might impact and society around us. Have you considered the actual needs of the people who touch it? Will it offer some choice so the people who use it have some choice in whether they participate? Is it equitable? All of these types of things that these questions are hinting at are probably questions that you might want to ask as you deal with complex issues. So not just focusing on the technical aspects, but looking at all the human and societal aspects as well. And in many ways, the Persed method is a structured and an explicit way of dealing with all of those types of questions. And in fact, this was a McMaster innovation within engineering, where we took all of these types of very complex and multidimensional questions, and we started grouping them into the Persed structure. Yes, technical performance is a very important thing. We start with that, but we also ask you to consider key elements of these other very important questions grouped in a structured way so that you can have a good experience in dealing with complexity during this course. So overall, it is part of what it means to be an engineering professional, to be able to deal with the uncertainties of complex systems like the ones we're looking at here. And in many ways, if you think about it, the vertical bars on this diagram, that talks about a lot of your courses on the technical topics, right? The sciences, computing, mathematics, all of that stuff goes into there, and it's going to serve you well. But courses like 1P13 and 2PX3 are really based on allowing you to apply those technical, those vertical skills, but apply them in a way that is broad and starts considering and being more inclusive of many more dimensions. And this is a way to help you not just deal with complexity, but have some more tools to deal with the core ethics and deal with, have a better chance of managing the unintended consequences that may come simply by pausing every once in a while and to ask more and more thoughtful questions. Pulling it all together, engineering ethics today is more than just doing the right thing the way we were taught or what the laws tell us. Really, it is about trying to manage and mitigate the uncertainties and the complexities of the complicated applications that we work on. And the techniques you're learning through 2PX3 and the Persed Method is a structured way and a proactive way for you to ask the right questions, for you to look at the challenges from different perspectives and to try to bring it together in a way that you can make better decisions.